Alright, Appendix R, Repair, Alteration, Conversion of Tanker Car Tanks. We're on page 15. This is video 2, part 4. Special requirements. For special commodity requirement, the tariff number BOE 6000 also for special commodity requirements, chapter 2, hydrogen fluoride and hydrious. Expansion, existing tank cars placed in the anhydrous hydrogen fluoride services must conform to chapter 2, paragraph 214. The anhydrous fluoride and hydrogen fluoride anhydrous tank tank shall be repaired in accordance with paragraph R24, table R2. While the repair blisters of the anhydrous hydrogen fluoride tanks shall be repaired by insert material shall conform with the requirements of chapter 2, paragraph 214. When required, radiograph and ultrasonic examination must be performed after post-weld heat treatment. Tensile strength of the joint tension specimens on the welding procedure qualification record must not exceed 85 kilo SI. Must have a carbon equivalent of CE of less than 0.42. The post-weld heat treatment should be done in accordance with the R19.0, and the temperature must be between 1125 to 1225 degrees Fahrenheit. The maximum hardness for the weld and heat affected zone after post-weld heat treatment shall not exceed 248 diamond pyramid hydrant hardness Vikers or 20 HRCs, which is brittle hardness test are not permitted on repair welds due to large size of the indenter relative to the features measured. However, the common practice convert hardness measurements to the brittle hardness values using published conversion tables. Portable hardness test methodology procedure shall conform with the following procedure provided with the technique with the portable hardness testers to screen with the hardness of the welds, base metal with the heat affected zone with the tanker car construction and repair. Micro hardness measurement devices with the Vickers diamonds indenter must be used. Kraut Kramer MIC10 power tool remove any of the rust of the fine corrosion pits, other roughness from the surface to be tested. Finish test surface with a high-speed medium sandpaper disc or wire wheel to create a suitable smooth surface. The surface finish with satisfactory when the majority readings are consistently within 1 to 2 units of rock LC hardness or 5 units of brittle hardness. At each test location, hardness for the base metal on each of the weld with the heat effective of the zone immediately adjacent to the toe of the welds and 3 readings across the face of the weld. The deposit itself must be tested and recorded separately on the both sides of the plate. Each hardness test location must be specified in 3 inch apart with a repair insert up to 12 feet in circumference. For repair insert larger than 12 foot in circumference, hardness test locations must be spaced in 6 inches apart. When tank repairs are made from one side only and subsequent covered with attachment fillet welds, hardness readings of the fillet weld metal tank attachment heat affected zone must be substituted provided with the same welding procedure specification used for both tank weld repair and fillet weld application. Alright, take 5 readings at each location, average of them together. The extremely large, small reading occurs, delete it. Continue taking recordings until average stabilized between changing less than 1 Rockwell C unit or less than 5 units of brittle hardness for with each of the new readings. And then 4122 is crossed out. 5.5.0 is damaged. Move to chapter 2, other TBD locations. And then 5 scratched out. 6. Acceptance criteria. Welding. All weld repairs of the tanker car tanks must conform with the applicable sections of the Appendix W, paragraph 2.0, 13.0, and 14.0. Non-destructive tests. All non-destructive tests resulting shall meet with the requirements of Appendix W, paragraph 10.0. 7. The materials specification. Materials repairs, alteration, conversions must comply with the material specification for the original tank. Must have comparable physical, chemical properties to be listed in Appendix M. Corrosion resistance. Procedure materials used to repair to high alloy steel tanks must maintain the corrosion resistant capability required with the tanks as originally built. Low hydrogen electrodes. Repair welding procedure involved with the use of the low hydrogen electrode. These must be handled in accordance with requirements of Appendix W to paragraph 1412. 8 is hardness test. That's been crossed out. 9. Repair of cracks. Tank cracks must be repaired by one of the following methods. For cracks, determine progress through the thickness of the tank shell by preparation of welding crack shall be in accordance with the figure R5. Interior and exterior reinforcement patch must be applied over the repaired area. By removal and defective of the area of the application for the weld and insert, expect with the nose, paragraph 13.2.2 below. 913 on riveted tanks, only removal of the defective area with the application of the riveted patch. 914 for cracks do not progress through the thickness of the tank shell, welding is done from one side only. See R132, R133, R134, R92 as applicable to CR24 non-destructive examination post-weld heat treatment requirements. 9.2 Welding cracks. When a crack of any type of the repair of the welding entirely discontinued, be removed by chipping the grinding and the air carbon arc plasma arc process. For the chip in the ground with the air carbon arc gouge, plastic arc gouge, grave groove cut in the base metal must be tapered toward plate surface to provide sound metal for the weld. On aluminum tanks, flame gouging and air carbon arc gouging must not be used. Reinforcement must be applied to the area where cracks have occurred. However, the cracks must first be repaired in accordance with paragraph 24.0. Reinforcement must then be applied by welding interior, exterior of the tank. Reinforcement must be of thickness at least equal to the original tank plate. See R24 non-destructive examination post-weld heat treatment requirements. 9.4 is crossed out. Refers repair surface cracks. Area of the tanker tanks that allowed reduced thickness of the Title 49-180 509G. Surface cracks 1/16 of the less than the depth may be removed by the grinding of sound metal, blending of the rounded area smooth with the surrounding plate and/or weld. If the area to be grounded is at the toe of the weld, the final surface must be free with the undercut and slag. Grinding must be accomplished. Transverse crack length unless the crack is along the welded toe. In which case the grinding must be along the length of the crack. Grinding marks the localized frictional heating of the grinding must be kept to a minimum. For handheld disc grinding, the disc should be inclined between 30 degrees 45 degrees. After the grinding, repair of the grounding area must be examined with the magnetic particle liquid penetration method. 10. Repairs of pits and corrosion. 10.1. Repair of pits and corrosion should be done in accordance with paragraph R24 welding purpose codes A and B apply. 10.2 Patch plate repair AAR specification tanks. Repair the corroded areas of the AAR class tanks may be made by the application of patch plate countered with the shape of the tank within 1 inch of the minimum corner radii. The minimum patch plate thickness must be equal to the original thickness the tank thickness of the plate. Material properties must be equal to the extent of the testing material properties of the patch plate must be limited to 24 inch circumferential width, depth, dimension between longitudinal fillet welds. If welds intermediate with the longitudinal fillet welds are used, if applied with longitudinal space slotted or plug welds, the maximum plate width is 48 inches between the longitudinal fillet welds. Repair pressure car manway gasket grooves. Repair gasket groove on the pressure car manway nozzle is to be made with removing the corroded and damaged material, applying welded metal, machining of the flanging face, recutting the groove, and see paragraph 24.0 for the appendix for the welding and non-instructive examination requirements. 11. Repair of deformation and scoring. 11.1. Dents and buckles. Dents and buckles must repair provided the procedure by which the areas are restored to contour does not damage the material, alter the physical properties of the material beyond the specification limit. Pressing or jacking. The sharper the radius formed with the dents and less than 4 times the plate thickness, such that the dent and buckle may be removed with the pressing or jacking to restore original contour to within the limits specified in the appendix W with the paragraph 13.5. The excessive heating of the metal should be avoided for carbon steel. Maximum temperature of 1250 degrees Fahrenheit, 677 degrees Celsius. If the temperature exceeds 1250 degrees Fahrenheit, 677 degrees Celsius, the affected area shall be repaired by insert. After complete removal of the deformation, exterior of the interior surface of the affected area must be examined. The surface cracking by liquid penetration magnetic particle method in accordance with appendix W with the paragraph 10. All welded seams of the deformed area and adjacent within the 2 inches of the deformed area must be radiographed or ultrasonically examined with the entire weld seam length and 2 inches beyond the deformed area. 11.3 Replacement. If the sharpest radius formed with the dents and buckles less than 4 times the plate thickness, if the material thickness that has been reduced, the effective area must be removed and replaced. Scores and gouges. Scores and gouges associated with the dents must be repaired with the restoring of the dent area with the original contour per paragraph 11.2 above. The scores and gouges must then be prepared by grinding air carbon arc or plasma arc gouging, sound metal removal, all upset metal, and rejectable discontinuities. The prepared area must have a smooth transition to the surrounding plate. Preparing the area must be examined with a magnetic particle dye penetration method in accordance with the appendix W paragraph 10. 11.4.2. If the plate has been reduced below the limitation shown below, it must be restored and replaced in accordance with the applicable reference paragraph 24.0. All DOT specification tanks, Title 49 CFR 18509. AR specification tanks, transportation regulated by the Hazardous Commodities, Title 49 CFR 18509. AR specification tanks, transporting non-regulatory commodities, and 1002 Appendix D, which this is Appendix C. 11.5. Wheel burn. All shell damage result of the wheel contact burn must repair by one of the following methods. If the wheel burn does not exceed 1/16 of an inch in depth and 6 inches in length, which is not limited, but can be repaired by grinding, provided shell thickness following the grinding is not less than the minimal allowable thickness for the general location must have the upside metal and rejectable discontinues removed for the repaired area must be examined. Material particle liquid penetration method in accordance with Appendix W to paragraph 10. 11.5.3. Wheel burns exceed the limitations of 11.5.2 must be repaired per paragraph 24. Welded inserts and tank sections when permitted on riveted tanks. Welded inserts and tank sections may be applied if the welding can be locally post-weld heat treated. On fusion welded tanks, welding insert sections may be applied to any part of the tank shell on the heads. On forged welded tanks, welded insert of the tank section may be applied to any part of the tank shell heads provided with the welds of the insert or not point closer to than 12 inches to any forged weld seam. 12.2. Procedure. Insert plate must have the double welded butt joint, dot 113, 115, and AR 204 W and 206W. Specification tanks can be welded with the one side of the backing using backing strips with 1 inch minimum corner radius. The insert must restore with the original contour. The insert material of the thickness equal to not more than 1/8 of an inch grade of the original material. See Appendix E. With the inserted material is thicker than the original material. The inserted material must comply with the material specification for the original tank. It must have the comparable chemical composition, physical properties equal to or greater than the original matter. Materials that used for the insert material must be listed with Appendix M in the relevant table for the material type. Heads repaired and welded inserts are considered to have the same weld joint efficiency with the original head. Head insert with the knuckle area with the straight flange must be ground with the flush or both sides. 12.3. Inspection of the non-pressure tank insert with the group. The uniform insert of the tank section. Tank heads are being inserted with the section of the series of the tank of the same material specification product. Basis utilizing the same welding procedure practice employed with the construction of the new tanks. The inspection requirements shall comply with the Appendix W, paragraph 18. Welding inserts of voided areas. Welding inserts in void areas. Indentation cracks in voided areas. Compartment tanks may be repaired by application of the insert. Refer to figure R9. The backing strip must be made with one piece circularly clamped and tack welded before utilizes a backing. Alright, 13. Riveted repair seal welding requirements. Riveted repairs must be made in the compliant with the specification recovering original tank construction. Riveted patches, when necessary for the removal of the section riveted tank shall because of the extent of the crack reduction in plate thickness or other defects too large or permanent the welded insert from being successfully applied locally post-welded heat treated. Riveted patch must be applied for that defective area replaced with the accordance original construction. Riveted patches may be applied with rubber line, elastometric line welded tanks when a welded repair will destroy the lining. A riveted patch must be replaced with the welded repair when the tank is relined. Seal welding. Seal welding inside caulking edge of the tank seam and insert with the rivet head with attachment outside caulking edge of the dome flange is permitted provided the throat thickness does not exceed 3/16 of an inch. Connections added and relocated when permitted. Additional relocated connections such as nozzles be added relocated on the dome head of the tank shell with the compliant with figure E21 through E2012. Procedures 14.2. Miscellaneous connection for the tank shell or the heads were addressed with relocated eliminated closure for openings may be fusion welded or by double welded butt joint or double full fillet lap joint. The closure may be riveted, not the permanence of the riveted connection for the weld of the tanks. So the computing riveting area of the effective diameter of the driven rivet of the diameter is reamed the hole. In the whole case, it is for the hole to exceed the nominal diameter of the riveted more than 1/16 of an inch. If the rivet is less than 5/8 of an inch, normal diameter is prohibited. 14.3. Removal of the rivet. The hole when welded inserts are applied with the cover of the riveted nozzle opening. The opening shall preferably be increased with the diameter of the riveted circle to remove the insert large enough to cover the entire area applied. Welding, rivet the holes when necessary. Clove with the rivet hole with the holes may be plugged well with the two-figure R6. Strips must be removed after welding prior to performing any non-destructive examination. Plug wells must be ground smooth if the tanks are to be lined. 14.5 Nozzle domes and welded tanks. Nozzle domes attached to the tank shell must be designed to meet the reinforcement requirements of Appendix E. Approved nozzle dome design welded attachments shown in Appendix E with the figures 21 through 2012. Alright. Other design nozzle domes or their attachments for the tanks may be used to provide reinforcement meet requirements of Appendix E. Welding is equivalent to that shown with the design figure E21 through E2012. When non-pressure tanks can be altered or repaired with the pressure tank cards with the converted with the non-pressure staff with the insert type nozzle application may be made, utilizing partial penetration well with the figure R10, subject to the following limitations. Application applied with the top fittings only. Joint gap not exceeding 32 for the inch with the joint grounded smooth with the reamed. Nozzle size must not exceed 10 inches inside diameter. 14.5.5 When no-pressure cars are alerted with the repaired when the pressure cars are converted to the non-pressure status, lap joint nozzle applications may be made in accordance with the R11. Permanent closure of the bottom outlet washout flange. Bottom outlet, bottom washout flange may be internally sealed with a plate with a tank or car tank with material with a minimum thickness of the car specification that weld with a continuous complete penetration groove welds or a combination of full fillet and complete penetration groove welds. CR24 and Welding Purpose Code 1 for the non-destructive examination post-weld heat treatment requirements. 14.7 Closure of the tongue and groove fittings interface. The lint fittings equipped with the tongue and the groove with the interface with the remove of the pressure card with the manway cover plate with the must be replaced with the tongue blind flanges that are accorded with the E-figure E27 to E28. When 3 inches full ported flange ball valves equipped with the ANSI B16.5 with a larger tongue design removed with the non-pressure cap car top fittings cover plate, they must be replaced with a U-fitting 3-inch ANSI class 300 blind flanges equipped with the ANSI B16.5 large tongue design. Alright, 15. Attachments added and relocated. Welded attached exterior interior bracket support with the reinforcement bar pads must be fillet welded to the tank shell per requirements of paragraph 20. 15.1.2 When adding relocating reinforcement improvements such as skid washout sums at the bottom of the stub steel tank cars require that Appendix E of the paragraph 15 must be met. These fillet welds must meet the Appendix W, paragraph 14.10 with the circumferential portion of fillet welds must be examined by magnet particle liquid penetrating include corner at least 3 inches of the weld extending longitudinal beyond the corner. Anchor rivet caps. One piece of the anchor rivet cap may be detached with the tank shell per requirement of the paragraph 24. Taped hole with the must be provided through the tank shell with under each of the caps to permit making an air test. Each test hole must be tightly closed with the proof plug. After completion of the test, caps must be tested. Applying air pressure to 100 psi must be tight against leakage. Welded bolster support. Welded steel tanks mounted on the underframes may be modified and attached to weld bolster support with the tank bottom reinforcement plate directly with the tank securely fastened to the underframe. When necessary, provision, expansion, contraction welding must be done in accordance with the requirement of paragraph 24. 15.4 Welded studded attachment. Studding weld with the carbon steel with the tank card. Tank should be done in accordance with the table R2. The stud welding of the tank card is made with the form P8 types 30411, 304L, 316L, P22, P25. Material shall be done in accordance with the table of the R3. Welding purpose code F applied with both tables. 15.5 Repairs in kind. Repairs in kind of tanker car tanks that have developed surface failure of the bolster anchor areas at the dome that shall interface with the bottom. Discontinue with the protective device must be submitted to Form AAR42 with a review adequacy of the original design. Alright, your 16 attachment sub draft sill has been crapped out. It said move to chapter 2. 17. Insertion in the interior tank cab with a head requirement of the AAR dot tanks may be altered the dividing of the into of the car compartments and by reducing capacity by the insertion of the interior head. The interior heads must comply with the requirements specified with the dot 179-206. Welding is inserted heads must be performed in accordance with Appendix E with the paragraph 6. Welding replaced heads must be performed in accordance with the paragraph 12 above. 17.3. Voids created. Void created with additional interior heads must provide with at least one tap drain with a hole for the lowest point with a tap hole for the top of the tank. The top of the hole must be closed, but the bottom of the hole may be closed with not less than 3/4 inch, not more than 1 1/2 inch. Solid pipe plugs having non-pressure type threads, MPT threads, non-destructive testing. All documents, film, tapes generated during the non-destructive examination process shall be retained for the period indicated in Appendix Y. All examinations are full length with extent of the preparer unless otherwise noted. 18.1. Radiographic examination shall be performed in accordance with Appendix T. Evaluation and acceptance of the indication in accordance with Appendix W, paragraph 10.2.2. Alright, liquid penetration examination. 18.2. Liquid penetration examination shall be performed in accordance with the paragraph T evaluation, Appendix T evaluation and acceptance of the indication should be in accordance with Appendix W, paragraph 10.3.2, 10.3.3. 8.3. Mechanic particle examination. Mechanic particle inspection should be performed in accordance with Appendix T evaluation and acceptance of the indication in accordance with Appendix W, paragraph 10.4.2 and 10.4.3. 8.4. Ultrasonic examination shall be performed in accordance with Appendix T evaluation, acceptance indication in accordance with Appendix W in paragraph 10.5.2. 18.5. When Appendix R does not specify the non-destructive testing welding to the tank, the car owner shall specify the suitable non-destructive testing method using personnel procedure qualified in Appendix T. 19. Post-weld heat treatment. When required, post-weld heat treatment for the tank of car tank steel tamped AR specification shall be done in accordance with paragraph 24. Any repair alteration involving the welding of the carbon steel pressure tank car tank must be post-weld heat treated. 19. Unit post-weld heat treatment after a welding applied to the post-weld heat treatment of the tank. The unit will double the end of the method of the preferable carbon steel tanks. Post-weld heat treatment of the tank as a unit is mandatory for the high alloy steel tanks except for tanks fabricated with a table type 304 and L and 316L materials. Post-weld heat treatment shall be performed in accordance with Appendix W, paragraph 16. 9.3. Local post-weld heat treatment. In the lieu of the unit of the post-weld heat treatment of the carbon steel tank, local post-weld heat treatment permit requirements before any employee of the certified facility or approved subcontractors, contractors review the AR Exhibit P1 subcontractor evaluation sheet to be completed with the retained the certified facility approved stress relieving equipment shall be used within such for the controlled gas heating, inducting heating, or electrical resistant heating system that will provide a constant uniform temperature for the welded area. Local post-weld heat treatment of the car's hydrogen sulfide strip is not permitted. Refer to Chapter 2, paragraph 2.1.2.2.1. Local post-weld heat treatment manually held gas torch is not permitted. 932. Requirements of local post-weld heat treatment. Minimum equipment requirements of automatic temperature recorder, heater and control unit, heater installation, thermocouple control cables. 9322. Heating treatment procedure. Minimum requirements. Heaters are proposed such as that the soak band meets post-weld heat treatment temperature requirements listed in the table W16, and heat band extends past the soak band a distance of 4 times the shell thickness minimum of the electrical resistance heating. The spaces between the heating elements shall be no more than nominal tank shell thickness. See figure R4. Heaters into the opposite side of the heating area to be covered in thermal insulation, reduce heat loss. 93222. To avoid ignition fire, sufficient insulation lining should be removed from the local post-weld heat treatment area. All thermocouple insulating pin with the heating area would be securely attached with the tank shell capacitation, discharge welding. Written welding procedures required. Neither qualification procedure nor performance qualification welder is required. 93224. Each heater circuit with the control zone to be have control thermocouple placed near the geometric center of the soak band. See figure R4. Alright, 93226. Heat sinks such as pad, bracket flanges, and etc. in the heat banded area to have insulated to prevent false temperature readings in the control zone. Alright, 913.227. To prevent harmful temperature gradient with the tank shell adjacent and prudency for the heater controls the unit with the monitored frequently local post-weld heat treatment technician during the entire heating treating cycle. Local post-weld heat treatment cycle temperatures are to be in accordance with Appendix W, paragraph 16.3 and 16.4. Thermocoupling insulation pins attached with capacity discharge welding should be removed with the tank surface to restore the original contour. 91323 equipment calibration. Temperature recorders to be calibrated. Heat controls aligned with an annually per written with the procedure and even the mark with the indicator of the day of the calibration alignment, status of the day of the calibration alignment, the next calibration alignment. The certificate is available upon request. 9324 documentation. Written local post weld heat treatment procedure required with the procedure shall as minimum coverage safe with the equipment calibration, thermocoupling, heating pad, and insulation plate with them remove on-site processing monitoring requirements, post-weld heat treatment temperature requirements specified in W16. Temperature time recorded is to be recorded with a strip chart recorded showing the thermocouple location, card number, the technician signature. Qualification of heating treating technicians. Low post-weld heat treatment technicians shall be qualified through the written training program conducted in either house or recognized subcontractor. The training program shall be the minimum cover the following areas: safety for the equipment calibration, thermocoupling, insulation, placement, processing, monitoring requirements as described in local post-weld heating procedure, post-weld heating temperature requirements as specified in W16. Technicians shall demonstrate the competency for the completing tasks outlined in the company's written local post-weld heat treatment procedure. Alright, show the typical element pad thermocoupler plate for the CT, the controlled thermocouplers, SB spare thermocoupler, tank shell 1/2 inch thick, heat plated element pad, heat band area minimum size. You have 4T 2 inches, 1T half inch, soak B and SB, soak band B, welding being treated. The SD, which is spare thermocoupler, and the controlling thermocoupler, a width of 36 feet, or is that inches, and then 36 inches, 1T half inch, 4T 2 inch, width of 1.5 inch soak band, heated band 41 minimum size, and then the maximum dimension between this heating elements of the pads is equal to T. Heat band of 5.5 inches, minimum size heating element pad. Heat element pad, heat band 5.5 inches minimum size. The soak band 1.5 inches. The controlled thermocoupler width of 1.5 inches, 4T 2 inches, 1T 1/2 inch. Post-weld heat and thermal placement. Heat band, soak band plus 8 times the T. And then you have soak band area welded 2 times the T. Soak band area welded 2 times the T. Controlled thermocoupling, spare thermocoupling optional. Welded area perimeter 4T all around, 1T in the all around. Heating element add. Heating area soak band 8 times. One pad, one control zone circuit. Alright, you have your heat area soaked plus 8 times. Soak band and welded 2 times. Control thermocoupling, spare thermocoupling optional. Welded area perimeter, soak band area welded 2 times T. Heating element pad and heating element pad, and the maximum distance between the heating elements pad is equal to T. And the heating pad L soak band 8.5 inches. That's 2 control zones, and then heat band area soak it 8 times. Soak band welded 2 times. Control thermal, spare thermal coupling optional. Welded area perimeter heating element 4T all around, 1T all around. Soak band area welded to 2T. Heating element, heating band area soak band plus 12 to 8T. Alright, your 3-pad control zone circuits, heating element, soak band, weld 2B, control temperature, and spare thermal coupling. Optional welded area perimeter, surface band welded 2 times T. Heat band area soak band 8 times T, 1T all around, 4T all around. 3-pad, 1 control zone. You have heat band, soak band 8 times T, soak band welded 2T, control thermal, spare thermal coupling optional, welded area perimeter. Heating element pad, heating element pad, heating element pad 1T all around, 4T all around. Heating area band, soak band welded 2T. Alright, figure 8-4, typical heating elements, thermocouple placement shown figure diagram R4 A, B, C, D, E, and F above. Variations of these placement may be necessary for special controls on requirements of the tank. To avoid problems during the heating cycle, the preferred application one with the thermocoupling properly placed directly under each heating element pad. Spare thermocoupling may be used for the control zone, keep the control thermocoupling malfunction. Thermocoupling location, thermocoupling plate from the heating element within the pad next to the large heat sink. Heating element pad can overheat with the tank while thermocoupling records. Small temperatures increase. Any large mass of steel with direct contact with the tank heating area will absorb large amount of the heat. Example, the heat sink reinforcement pads, mounting flanges, nozzle, bolsters, drafting sills, webs, exterior coils, the heating and insulation of the area is critical for the heating element to be placed directly again with the tank shell. Thermocoupling attachment made directly with the tank shell. P6 pad spacing shall not exceed with the tank shell thickness. T soak band volume of the metal required to meet the post-weld heat treatment requirement listed in the table W16. Minimum soak band shall contain the welded heat effector zone portion of the base metal adjacent to the welding being heated treated. Minimum width of the volume of the width of the weld plus 1 T on each side of the end of the weld. The term T is the nominal thickness of the heat-treated material. Heat band controls the surface area with a heating element to apply with achieve the required temperature from the soak band. Minimum heated band area shall contain a soak band of 4T, 4 times the thickness at each side with the end of the soak band. T, the defined with the nominal thickness of the heat-treated material. The heat band must be wide with the required soak band compensation conducted with the heat loss of the adjacent unheated section of the workpiece. Convection, radiant heat loss of the workpiece surroundings. Alright, 20. Hydrostatic testing. In addition to the non-restrictive requirements, hydrostatic testing pressure car tanks is required with the following repairs: alteration, complete penetration weld of the tank, such as insert rings and head through wall repairs. CD4. Application requirements: relocation weld of the components to retain pressure in the nozzle flanges. Some CD4. 20. Repair to anchors. Requirement that when necessary to remove the fastener from tank anchors for any reason, the fastener must be not reused. Fastener be replaced with an in-kind except the otherwise known with the paragraph 15.5 above. Bolts used to replace rivets and the two-place rivets or two-piece rivets must be ASTM 325. Washers, if used, must be hardened steel. Hardened steel, if permissible, with a plate with a discard fastener with a bolt with a two-piece rivets to the space within the car owner. Car owner or owner authorized agent must comply with the following: the ultimate shear strength with a bolt with a two-piece rivet that's securing with the anchor of the underframe must not exceed 70%. Ultimate shear strength with the welds with the continuing anchor of the tank with the anchor designed with the utilize more mechanically fast connection within each leg. The 70% requirement need not only apply to the connection limited to the original design, not exceed 70% of the shear strength with the welded connection between the tank and the anchor. The shear strength of the connection must be equal to the shear strength of the connection from plate for the prepared to Chapter 5, Paragraph 5.2 with the design and installation criteria for the allowable fasteners. Do not relocate SU. If necessary to work with a fastener hole, final diameter must be reamed. If in the case of the diameter resulting, the hole must not be greater than 1/16 but larger than the nominal diameter of the fastener. Result of the connection with the unused fastened hole that may not be closed with the welding will cover the plates using holes to eliminate. Do not eliminate consecutive holes or end with the holes. Repair to fire damage or heat damage tank or car tanks. 22. 22.1 Requirements. 22.1 Parts portion of the tank or car tank that have been exposed with the fire heat sufficient for the render of the performance unsafe that must be replaced. R25 Local post-weld heat treating provision with the temperature limitations. 22.12 Unsafe parts or portions that must be identified. Physical testing removed by material by evaluation of physical condition of the material of the tank or car tank, such as paint, film, insulation, gasket material, surface oxidization film, etc. 21.3 Detailed evidence, safe condition, any portion of the tank of the car tank that is to be retained on all surfaces must be submitted with approval using form AR 42. 2214 All valve fittings must remove the overhaul test in accordance with the valve manufacturer instructions suspected overheating. Alright, 23. Repair of the taped hole. Requirements of the taped hole for the flange to cover the blade with the damage mechanically by corrosion. Maybe the repair of the thread insert provided with the following conditions are met. Insert insulation in accordance with the manufacturer's specification. Insert material with the compatible with the commodity surface after drilling with the damaged fit of the metal surface free of the defects before retapping the insert. Nominal thread side of the insert to match for the original side with the existing taped hole. Original high holes are not permitted. Each modified hole must be tested application for the carbon steel with a trait hardener for stainless steel stud. Should live with the lower following. 23151, 55% of the minimum test strength of pounds of the stud, which may be elevated with either the tensile strength stud with the specification stud and bolts, or the tensile strength with the stud material with the PSI with the specification with the stud and bolt materials multiplied by stress area with area corresponding with a minor diameter of the stud of the bolt. The result of the shear stress equal 40% of the yield strength and the PSI and tension with the flange covered parent metal evaluated with the outside diameter of the insert, where P is the pounds is equal to 0.4 times pi times the outside diameter insert in inches times the depth of the original threads in inches times the yielded strength of the flange cover material, or equal to P is equal load is equal to 1.25 times D outside diameter in threads, depth of original threads times the yielded strength flange cover material. Testing must be done using the direct tension indicator following manufacturer specification using the calibrated torque wrench. Alright, 24. Welding tank to tanker car tanks. Welding the carbon steel with tanker car tanks after using the post-weld heat treatment. Additional welding is not necessary for the following unit. Post-weld treatment. The following are applied with the carbon steel tanks are categorized in R2, table R2, see paragraph 4. Appendix additional of the anhydrous hydrogen fluoride tank can be tank car repair requirements. R2 process additional welding the carbon steel tank cars. Car categories are A through J. And the A is your yeses on the PT and MT after removal of the imperfection prior to welding. The yeses are A, B, and J. Your post-treatment MT and PT and MT. Yeses would be A and B. RT ultrasound radio particle tests, magnetic tests after welding are in A and B. Radio technology ultrasonic testing is yes for A through and G through I. Post-weld treatment is in yes for all except for the C. Pressure category C cars. Non-pressure car tank portions of the A through J. The yes is for the particle and magnetic after removal of the imperfection prior to welding would be A, B, and J. The particle magnetic tester after welding would be yes for the A and B. And then yes would be for the radio technology ultrasonic testing. Yes would be your A, your G, and your I. And then your post-weld heat treatment would be A, B, E, F, G, H, I, J. Non-pressure cars portion thereby built on training circular 128. Or TC 128, I think that's what it means. TC built from TC 128. AB portions, your post-medical particle magnetic treatment after removal of the imperfection prior to welding would be A and B and J. Your particle magnetic test after welding would be A and B. Your radio testing, ultrasonic testing would be A, G, and I. And then the rest of them would be post-weld heat treatment, everything except for C. If the tank material is 430A of the repair welds intersection all longitudinal circumferential, complete penetration butt joints in the tank must be radiograph ultrasonic tested after post-weld heat treatment. And footnote B, when uniform insert tank steel sections heads are being welded in a series of a tank of the same material using same welding procedure practice with new construction, but the inspection must comply with the appendix W, paragraph 18. Alright, footnote E, if the repair is within 4 feet of the bottom longitudinal center line. D, with C of the appendix W, paragraph 18 for the inspection requirements. E, footnote E, required tanker car tank steel stamped AR specification. F, footnote F, welding procedure with a minimum of 300 degrees Fahrenheit preheat temperature may be used in lieu of post-weld heat treatment. G, and fillet weld size exceeding 15/16 with an inch length of 24 inches. C, footnote post particle treatment and magnetic test required only in the defects of the crack. Alright, 24.1.1, welding in aluminum stainless steel tanker car tanks and hydrostatic testing. Additional welding is found necessary in following hydrostatic tests following appliance for the tanker car fabricated materials TM M102 and M103. Alright, categories A through welding purpose codes A through J, particle transfer test, particle Particle testing after removal of the imperfection testing of the weld would be A, B, and J. Post-particle testing after welding would be A and B. Radiotechnology ultrasonic testing would be performed in A, N, G, H, and I. When uniform insert tank section heads are being welded on the exterior of the tank, same material used the same welding procedure practices for the new constructed inspection must comply with Appendix W, paragraph 18. If the repair is within 4 feet of the bottom longitudinal center line, see Appendix W, paragraph 18 for the inspection requirements. Your particle test required only in the defect if it is correct. Alright, now we get to the welding purpose codes. Code A. Repair defective area of the tank shelf, tank heads of the nozzle after preparation of the welding greater than 3/16 of an inch in depth and any width of the length. Repair of the weld built up is included. Point B. Code B. Repair defective area of the tank shelf, tank head of the nozzles after the preparation of the welding equal to less than 3/16 of an inch depth of any width or length of the repair of the weld buildup is included. C. Fillet welding, weld buildup applied with the nozzle flanges, fillet welding applied with the nozzle. When weld with the tank shelf of the tank head is involved, see welding purpose code F and or H. Code D. Repair exterior coil fillet weld with a length of 6 inches or less. Code E. Repair exterior coil fillet weld with a length over 6 inches. Code F. Add or replace attachment tank head, tank shelf, fillet welding, stud welding, including temporary welds. Code G. Underline. Complete penetration nozzle butt joint groove welds. H. Attach to tank head, tank shell by groove welding. I. Groove weld insert closure of the referred to 12 and 14.6. J. Repair attachments and fillet welds. Alright, 24.1.3, local post-weld heat treatment. Local post-weld treatment may be used to provide minimum heated area includes the soak band and the heated band is defined in figure R4. The temperature distribution must be controlled as follows. 24.131, above 800 degrees, rating of the heating shall be no more than 400 degrees per hour divided by the tank thickness in inches, but no, which is divided by the tank thickness in millimeters, or divided by the tank thickness in inches, but in no case with more than 400 degrees per hour. During heating and holding cooling periods, the temperature edge of the heated band shall not be less than 1/2 of the temperature of the edge of the soak band, nor shall any portion of the 1250 degrees, if the recorded local post-weld heat treatment temperature exceeds 1250 degrees, the affected area shall be repaired by insert as minimum of the affected area shall be the same size as heating pads or pad. 24.134, above 800 degrees Fahrenheit, cooling should be done at a rate no greater than 500 degrees Fahrenheit per hour, divided by the tank thickness of the inches, but in no case more than 500 degrees Fahrenheit per hour. Below the 800 degrees Fahrenheit, the tank may be cooled in still air. Our figure I4 show the double V groove. No, it's just a bevel groove. It's a bevel groove. It's single bevel at 60 degrees angle, and then you show the rivet holes with welding rivet holes inside of the tank at 45 degree angle on the backing bar, and then I guess this would be a lap joint bevel at 60 degrees angle, joint separation, and then the bottom strings over the lap, and welding fracture actually extends into the riveted area. And shove the backup strip with a 60 degrees angle and a fillet from the root of the root backup strip, and then it's filled in 6 times flatly. Like instead of 2 and 3 and 4, it's done them all in one layer. These are insertion and application void area of the compartment car. You have your backing strips on the side with a tank shell to maintain 1/4 inch gap in between the spaces between the tank shell insert patch. The backing strip is 3/16 of an inch, 1.5 inches, and 1.5 inches on both sides of the weld. 30 degree angle on each side of the, so you have a 60 inch, maintain 1/4 inch gap, 30 inches on each side of the single V groove, 7/16 of an inch thickness tank shell, and then, insert application void compartment car, 1/4 inch radius inside, and then the space between the 3/4 inch and then 1/2 inch on the outside of that. Backing strip must be continuous, edge of the cutout. Alright, you have A and center, B and center line, 10-inch maximum, actual 3/32 of an inch gap, 2/3 of an eighth of an 3/32 of an inch maximum gap. T1 and T2 not less than smaller than 1.5 and 1/4 inch of the 0.7 T minimum, and T plus 1 plus 2 equals 1/4 1 and 1/4 T minimum. Insert type nozzle application reference appendix 14.5 for the appendix. Alright, this is center line symmetrical. You have M, and then it shows the different degrees. It's a lap joint with 2 fillet welds, and then it shows the center line break. And then here is a another lap joint filled on 2 sides, smaller than 0.7 ends or 0.7 is minimum M's. Note that 1 T minimum thickness minimum comply with the maximum minimum set by tank specification. So you have your lap joints filled with a closed joint with a ground off. Form SS1 report tank car stub still inspection. To car owner 1, 2 reporting mark and number reported by 3, 4 performed at, 5 by date, 6 by tanker car builder, 7 by build date, 8 by current AR certification, 9 by commodity, 10 control tanker specification, 11 stencil tank spec, 12 car jacketed yes or no, 13 top bottom shelf couplers yes or no, 14 head shields yes or no, 15 prior level for this inspection, and then priority level for this inspection, 16 head braces, yes or no. Inspection rules in your A, B, N, and A and N and B N, the A axle right and left, BN right and left. If the draft sent by bent, warped, yes or no. Any of the past couplers, yes or no. Any damage for the front draft lugs, any damage for the rear draft lugs. The 22 described prior sill repairs. 23. Inspect the defects of the weld. Note inspection methods. Use AE acoustic, F fiber optic, liquid penetration, LPV visual, other explain. Alright, you have your method AN and BN, A1 pad to tank transverse, B1 pad to sill transverse, C1 brace to sill transverse, D1 brace to pad transverse, other transverse described. Then you have method AR, AL, axle right and left, and BN axle right and left, A2 pad tank long, B2 pad to sill long, C2 brace to sill long, D2 brace to pad long, other long described. 24, describe the location and nature of the defects. C2 3-inch crack weld is like not just as example. Disposition of cars. 25, inspected by and title. Alright, instruction for completing Form SS1. SS1 reports by type written and printed with a legible manner must be submitted to the car owner. Following instructions must be filed with the filling out of the report. Line 1, enter for the company name of the car owner. 2, enter for the car's reporting mark number. 3, list of the company reporting the work whether it was performed. 4, list of the faculty, location performing the work. 5, the date of the must be within which the work was completed. 6, list of manufactured tank cars. 7, enter for the original built date with the tanker car. 9, show the most recent AAR certification number under which the tanker car is currently approved. 9, identify the company with the transport of the tanker car. 10, show that the tank specification is built. 11, show that the stencil tanker specification of the tank car as operated. Enter Y, yes, Y for yes, N for no, indicate the car is jacketed. 13, yes or no, indicate that the car is equipped with the top and bottom shelf couplers. 15, indicate priority I, inspection required per paragraph 5 of the appendix. 16, enter yes or no, that indicate that the car is equipped with the head braces. 17, enter yes or no, indicate the evidence of striker damages in 2 places. 18, enter yes or no, that indicate still is bent or warped in 4 places. 19, enter yes or no, indicate evidence of still damage due to past couplers 4 places. 20, enter yes or no that indicate the evidence of the damage of front lugs or 4 places. 21, enter yes or to indicate evidence of the damage rear draft lugs 4 places. 22, describe prior still repairs present. 23, indicate inspection method utilized. Examine each of the weld. Prefer the illustration either yes or no to indicate evidence of the defect with adjacent to the welds of A1, B1, C1, D1, 2 plate for the A2, B2, C2, D2, 4 places. If the design incorporates with the weld, describe them and indicate the inspection method the result as above. So you have your illustration of the weld, inspection method, the bolster, the draft gear, and then the tank shell. Um, and over here, a side shot. 24. Describe location, nature, effect with final reference to lines 17 through 23. 25. Indicate with the disposition card found by the inspection return surface of repair and scrapped. Inspector must sign in the report. And then the last page is intentionally left blank. And this was the reading, the last tape, the Appendix R, repair and alteration, conversion of tanker car tanks.